the last kind of big topic area, technical topic area to go over is this idea of compression.
Yeah.
So in papers, you've discussed how the brain compresses representations for future planning and previous trajectories, so-called hippocampal replay. A recent paper called Language Modeling is Compression by DeepMind and Meta explores the relationship between prediction capabilities and compression. So your work emphasizes predictions and compression as key elements in representation learning. So I feel like maybe we haven't even talked about, maybe we need to define representation learning, which we haven't probably done specifically. But then, yeah, I'm sure you have lots of interesting things to say, related to this compression and how it relates to both the brain and artificial systems.
Yeah. So representation learning generally is this problem of learning how to represent your observations. You have all of these things that you experience. What is the format that this experience should take? If I think about this current setting I'm in right now, I'm sitting at this table, I'm mic'd in, I'm in the middle of speaking. Like, these are all aspects of my experience that I want to represent in some way, that have some relevance to like what I'm about to do. And I don't want to get distracted by irrelevant things. If I'm in the middle of a sentence, I really want to remember the beginning of that sentence, but maybe I don't need to be aware of like the cool strap on that guitar with its bird pattern. Like, that's kind of neat, and I could access that knowledge in a different situation, but being able to focus on specifically relevant information, not getting distracted by other things, is really important. The flip side of this is if I wait for experience to justify every bit of information before I learn anything, I just haven't constructed enough of a map. I haven't really been using my knowledge or my experience and organizing it in a way that can support any information. So representation learning is what sort of objective should you use to learn a representation? What information is relevant? What is irrelevant? What should I keep around? How do I represent it in a way that is both expressive enough and compact enough to support intelligent but also efficient behavior? So prediction and compression are two objectives really that come up in this. Prediction, when cast as an objective, is saying, I want to be as good as possible at predicting what's going to happen next. I want to be able to make predictions about what's going to happen because whatever is relevant to predicting things in the future, that's probably something that's not just random noise. It's something that'll at least persist in time for a little bit. Maybe that's an outcome I want to maximize at some point. Compression is more about how do I represent things succinctly. How do I try to have short descriptions of what's going to happen? Have a sort of more. It's a way to summarize events rather than expressing them in their full detail. This can be useful for efficiency. You just have fewer things that you have to learn about if you have a more compressed representation. It also can be really useful for identifying abstractions. One of the things that emerges when you apply compression, when you try to make your descriptions be more succinct, is that you get more overlap between related ideas. And this is really useful as a way to start getting some elements of abstraction out. So for instance, if I want to, if I have lots of pictures of elephants that I've seen, I can represent them more compactly if I just have the concept of an elephant, and here are lots of specific instances of it, but I have this more general concept that unifies them all with a single description. I might also have a compression or a compact representation of all of the things I've ever seen before that are pink. And there's maybe different kinds of instances, they manifest in different ways, but there's one property in common, which is pink. And if I try to have a compressed representation, that's a concept that might emerge. And as it relates to abstraction and compositionality, once you kind of have these things pull out and part of a compact summary, you can start reasoning about more interactions between them. I can now have a pink elephant because pink is something that popped out and elephant is something that popped out, just diff compression. So it's useful just for efficiency, but it's also useful at a deep level for trying to extract patterns and rules in the world.
Yeah, so this all makes perfect sense. So representation learning is just this general idea that we are probably familiar with anecdotally, subjectively as individuals, where it's just the representation of information, and as we do that, we want to compress that information as succinctly as possible, probably in as many circumstances as possible, so that that reduces cognitive load. So we want these representations to be efficient, which allows us to have kind of more thoughts and that allow us to hopefully be able to make predictions better, get more dopamine reward per unit of mental effort in the planning that we're doing. And then, so you saying that, it seems almost trivially obvious that language modeling is compression, because it just seems extremely obvious that saying the word elephant and that being able to represent a big gray object with 4 legs and a nose and big ears, it's like you compress all of these ideas about an object into a few syllables, into one word, elephant. And we make up words for theoretical concepts like corporation and love. And so you're able to compress huge complex things into a single word. And then that makes it easier to play around with these and have them bump into each other and think about a loving company or something, which like if you don't have these words, it could be difficult to think about these quite disparate concepts together.
Yeah. Yeah, I think absolutely. I think one thing that was a cool aha moment for me was realizing that I used to think of compression maybe as just like something you had to do because you had limited resources. Like the brain is not infinite, we have working memory constraints, we have only so many neurons and only so much food to power them. So you have to compress stuff. But I think this idea that it actually has enormous computational benefits too, that it's a deep part of the reasoning process where you identify commonalities between different situations can be expressed as compression, was kind of cool. That it's not just kind of like a compromise or something that you have to do in order to make it work, but it actually has real advantages.